So question 10, the last question on the Year 12 June exams. It says a curve has equation y equals g of x. Given that g of x is a cubic expression in which the coefficient of x cubed is equal to the coefficient of x, the curve with equation y equals g of x passes through the origin. The curve with equation y equals g of x has a stationary point at 2, 9. Find g of x. So we know it's a cubic. So let's start off by writing a cubic equation where the coefficient of x cubed is equal to the coefficient of x. The coefficient of x squared could be different. So I'm going to write a different letter in front of that one. I know it passes through the origin, so it would have this plus 0 on the end, which I don't really need to bother writing. So that's the first point dealt with, and the second point dealt with. Now, if it's got a stationary point at 2, 9, I know that the curve goes through 2, 9. So I know that x equals 2 and y equals 9 can be substituted in here. So when y is 9, x is 2. So 2 cubed plus b, 2 squared, a, 2. So let's just tidy that up. So 2 cubed is 8. 2 squared is 4. And then let's just group the like terms together. So 9 equals 10a plus 4b. So I've used this in one way, but also we know that stationary points occur when the differential of the function is set equal to 0. So let's find the differential of this. So dy by dx, this is 3a squared when I differentiate it. This is 2bx, oh, I forgot the x there, x squared. 3ax squared plus 2bx plus a. And it's when that is equal to 0. So 3ax squared plus 2bx plus a is equal to 0 when x equals 2. So let's substitute x equals 2 in there. So 3a 2 squared plus 2b plus 2 plus a. And let's just tidy that up. So 4 times 3 is 12. So 4b plus a equals 0. So that's 13a plus 4b equals 0. And now I've got two simultaneous equations there. I've got that one up there, and I've got that one there, and I can solve them to find a and b. So let's rearrange this one. So b is equal to 9, take away 10a divided by 4. And I'm going to substitute that in here. So 13a plus 4 lots of 9, take away 10a over 4 equals 0. So that's nice, those 4's cancel. So I've got 13a plus 9 minus 10a equals 0. So 3a plus 9 equals 0. I can solve that for a. So minus 9 over 3 is -3. So a is -3. And then I just need to substitute this into this and I can find b. So b is 9 minus 10 lots of -3 over 4, which is 39 over 4. So B is 39 over 4. So I've got A and B. I just need to substitute A and B back into my original cubic, and that's the answer for part A. So y equals -3 x cubed plus 39 over 4 x squared minus 3x. So part B says prove that the stationary point at 2, 9 is a maximum. So we can tell the nature of the stationary point by finding the second differential, and we know that it's at x equals 2. So if we substitute 2 into it, if it's less than 0, it's a maximum. If it's greater than 0, it'd be a minimum, and if it's equal to 0, it would be a turning point. So we've got our cubic. I will just write it out up here so that you can see it at the same time. Our first differential is -9 x squared. So we take the power down, subtract 1 from the power. 39 over 2x minus 3. And then our second differential would be -18x plus 39 over 2. So when x equals 2, we did do some of this work over here, so I have to replicate it a little bit. So when x equals 2, d2y over dx squared equals -18 lots of 2 plus 39 over 2, which is definitely less than 0. Okay, so as d2y over dx squared is less than 0 at x equals 2, 2, 9 is a maximum. Great, that's the paper done.